So it's going to be stuff like we're going to look at what the definition of a parallelogram is, and then we're going to be able to classify the different kinds of special parallelograms, rectangles, rhombuses, things like that. Okay. All right, so let's look real quick at.
Do you ever get into like geometry stuff again?
What do you mean by?
Next year, like algebra 2 stuff?
Oh, algebra 2 stuff. Yeah, what we're going to do, well, what do you mean by that? Makes sense. Okay. So the first thing you got to do is you have to see if the Hinge theorem applies, right? Does the Hinge theorem apply here? Do we have two boards, essentially, right? Two boards of identical length and a rubber band stretched between them. So in geometry terms, do we have two sides in one triangle congruent to two sides in another triangle? Okay. What do you think? What do you think? Caitlin? We got triangle on the left, triangle on the right. They tell us one pair of congruent sides, but we need another one. We have to add it ourselves. Where's that going to be?
No, the middle.
The middle. Yeah, they share a side, don't they? Good. Okay, so we can do this. We could say they share that side, and then what you really want to do here, I think, is, and you got to start doing this. This is going to be the difference between doing well on the test and not doing well on the test, I believe, is put this picture on your paper and then separate the triangles. So if we separate the triangles, isn't it just going to look like this? The left triangle is triangle A, B, D, D, and the right triangle is triangle C, B, D. And if I transfer the congruences, we've got that, right? Okay, so what are the rubber band sides then? Brady, what are going to be the rubber band sides in the two triangles? The two congruent sides? Because remember, the rubber band side is the oddball one. That's the one that's not part of the two pairs of congruent sides, right? These are the boards, right? I've got boards of the same length, right? So where are the hinges? Which angles are the hinge angles? We'll say it again. So angle ADB, right, is what they called angle 1. And angle CDB is what they called angle 2. So these are the hinges, right? The hinges are at vertex 2. Everybody see that? So where are the rubber bands in? Okay, yeah, so it's going to be AB is a rubber band and BC is a rubber band, right? And we're just trying to determine, okay, based on the rubber bands in this case, which hinge angle is bigger? Well, they're telling us that rubber band BC is stretched out to a length of 14, and rubber band AB is stretched out to a length of 12. So does that tell us something then? What's that telling us? What do you think, Shaw? So I got identical triangles, except this rubber band is stretched out more than that one. So what's that tell you about the relationship between angles 1 and 2?
2's bigger?
Yeah, measure of angle 2 is bigger, isn't it? Right? Okay, so right here, I guess, right? Measure of angle 1 is less than the measure of angle 2 is the same thing as saying the measure of angle 2 is greater than the measure of angle 1. Okay, make sense? Let's try another one. Okay, how about that guy? So take a second, get out your notebooks if they're not out, and see if you can set this one up. Okay, separate the triangles, add the other pair of congruent sides, maybe identify which is going to be the rubber band side. See if we can come up with a relationship. Okay, so Casey, is there another pair of sides? We need 2 pairs of congruent sides. We've only got 1. What's another pair of congruent sides? AD, good, they share a side. So we got AD, which I can add over there. So then, which side is going to be the rubber band side, Justine? On the, how about on this triangle? Which one's the rubber band?
Let's see.
Say,
I don't know.
what do you think? What do you think, Trinity? So for this triangle here, which side's going to be the rubber band side? AC, right? Be the one that's not one of the congruent ones, right? So there's the rubber band in this triangle. And so Justine, where's it going to be in this triangle? In the right triangle? BD, good. Okay. Good. And what do they tell us here? We can add some lengths. They tell us the lengths of the rubber bands. So AC is 23 and BD is 25, right? So then we've got these angles. We've got angle 1 and angle 2. So which hinge angle must be bigger?
Measure 1 is less than measure 2.
Yeah, it's got to be less, doesn't it? And it works because we've got same length boards, right? And different length rubber bands. So we know 2's got to be the bigger one. It's right there. Okay, make sense? Okay, one more of those before we try something different.
I have a question.
Yeah, oh, oops.
Couldn't you, like, I know, like, it's good to, like, draw it, but since it says AC is 23 and B is 25, couldn't you just, like, assume that B is bigger because the numbers bigger? Like, 25 is bigger than 23?
Well, right, you can't. You can't. So, I mean, maybe you don't need to redraw in this case. I mean, maybe it's, and once you get some more practice, you probably won't have to, right? Okay, but now I want to put one up here that you gotta, it's gonna make you think about something that I haven't put up yet. I mean, it's a little bit different problem. Try this one, and this will be important. So really pay attention to why this one's different. Okay, they're already separated, so that's kind of nice. But what's different about this one? Something is okay, and that's true. And I'm gonna hide that for a second. We don't even really need to know that so much. But you're right, that is different. But what if we didn't even know this information yet? To even see, we're trying to compare angles 1 and 2, so those must be the hinge angles, right? The rubber band is always opposite the hinge angle, right? Okay, but what's the problem with this one? There's still something different about this. What do you notice, Shah?
They don't share a side.
They don't share a side, and we're not given any information to tell us that AC and DE are congruent, right? You see what I'm saying? And so does the hinge theorem apply here? It doesn't apply because it really, even though they tell us, they end up telling us the lengths of the rubber bands, it doesn't really matter because we don't know that the lengths of the 2 boards are the same, right? And so we can't make a direct comparison, can we? Right? Doesn't it make sense that if I had, let me draw a slightly different picture. Let's say we've got these 2. I've got these 2 triangles with rubber bands. And I know that these sides are congruent, but the other boards are not. Even though, would you agree here that in this case, even though it looks like angle 2 is bigger than angle 1, the rubber band opposite angle 1 is still stretched longer? How come? See what I'm saying? How come this rubber band, even though this is a bigger angle, how come this distance is still greater than, this rubber band is still stretched more than this one?
It's longer.
Yeah, because one of the boards is a lot longer in the top triangle, right? So the Hinge theorem doesn't apply, does it? Right? The Hinge theorem only applies if we have two pairs of congruent sides that can be the boards. So what's the right answer here? Not enough information, right? Okay, that makes sense? Okay, let's flip this around. Let's take a couple problems where this time, instead of giving us the lengths of the sides like they did there, instead they're giving us the angles. It's really no harder. So how about like this guy? A lot of stuff going on there, right? A lot of stuff going on there. And maybe we could even like erase some things. And I can do it because with my whiteboard I can actually do that. But what you could maybe do instead is like redraw this without all the extra information, extra extraneous, confusing information on there. So what are they telling us here? Let's add some congruence marks. They're telling us that length AB equals length BC. So what could I do? I can add a congruence mark, right? I can do this. Do we know any other congruences? Yeah, they share a side. And look what we're trying to relate here too. I guess I need to maybe go down just a little bit, huh? Oops, I lost my congruence mark. Let's do that again. So I know these sides are congruent. We're trying to compare sides AE and CE, right? And they're giving us information about the angles. So if these are the hinge angles, 1 and 2, what are my rubber bands this time? Or sides what? Yeah, does that make sense? AE and CE, right? So there's a rubber band, and there's a rubber band, and it turns out that a lot of this stuff is we don't even need, right? We can get rid of a whole bunch of this stuff. Don't even really need any of that garbage, do we, in this problem? Right? Okay, and then so what other side, you already told me, what other side could we also say is congruent? They share a side here, which, what was that? That was a E? Yeah. E. Okay, so now what are they telling us? They're telling us that the measure of angle 1 is less than the measure of angle 2. So which side is going to have to be stretched more then? Which rubber band is going to be stretched more? If the measure of angle 1 is smaller than the measure of angle 2, so this angle is bigger. Okay, so Abby, what do you think? Which rubber band is going to be stretched more? AE? If this angle is bigger than that one?
Oh.
Other way around maybe, right? So it'd be CE? Does that make sense? This has got to be a bigger rubber band. It's got to be stretched more than this one is because this angle is a little bit bigger, right? Does that make sense? Okay, so we said CE is a little bit bigger, so right there. Okay, try another one. Let's get a little harder one. Okay, let's try this guy. Okay, what about this time? What congruence can I add this time?
Attention please, attention please. At this time, our school is in lock-in. Again, we are in lock-in. Secure students in room immediately and follow lock-in procedures.
Okay, that's not as bad as locked down.
Attention please, attention please. At this time, our school is in lock-in. Again, we are in lock-in. Secure
Okay.
students in room immediately and follow lock-in procedures.
Quick, go to the corner.